Namaste. In this session, we are going to discuss about the chapter Dual Nature of Radiation and Matter. So already I have discussed one session related to this chapter. So in that session, we have discussed till the experimental observation on photoelectric effect. So there I have did one diagram. Do you remember? So in that diagram, it consisting of a evacuated quartz or a glass chamber. In it, it consists of a photosensitive plate C and a collector plate A, and they were connected to the battery, and there the quartz window is connected to the evacuated glass chamber, and the cumulator permits the collector plate A as positive or negative with respect to the photosensitive plate C, and the potential were measured through the voltmeter and the current were measured through the current meter. So till there we have discussed in the previous session. So in this session we are going to discuss about the effect of intensity of incident radiation on photoelectric current and effect of potential on photoelectric current and effect of frequency of incident radiation on stopping potential. And later we are going to discuss about the laws of the photoelectric effect. Okay. So first let us discuss about the effect of intensity of incident radiation on photoelectric current. So what is the effect of intensity or effect of intensity of incident radiation on photoelectric current? So I am going to draw one diagram for it. So this diagram, the photoelectric current versus incident radiation. I mean the intensity of incident radiation. The diagram for this, graph for this will be like this. It is straight line. So the effect of intensity of incident radiation on the photoelectric current. So here the frequency of incident radiation and the potential difference between the photosensitive plate and the collector plate made constant, then the intensity of incident radiation is varied. The photoelectric current will be noted in a micrometer, and it is found that the photoelectric current increases linearly with the intensity of incident radiation. Therefore, it is like that the photoelectric current is directly proportional to the intensity of the incident radiation. So, this is the effect of intensity of incident radiation on a photoelectric current. So, they are directly proportional to each other. When the frequency of incident radiation and the potential difference between the photosensitive plate and the collector plate made constant. So the second one is effect of potential on photoelectric current. Effect of potential on photoelectric current. So I will draw the diagram before explaining. Yes, this is the graph. The graph before explaining the explanation. I am going to draw the diagram. This is photoelectric current. This is potential. This is also retarding, decreasing potential. And this is the stopping potential. Okay, this is a graph for the effect of potential on photoelectric current. Okay, this is a graph versus photoelectric current versus potential. So you can see here one point, that is V0. I have mentioned it as a stopping potential. Yeah. So here this photoelectric current can be varied or can be increased or decreased by varying the potential difference between the photosensitive plate and the collector plate, right? That is, we have studied in the previous session in the experimental observation on a photoelectric effect. So this photoelectric current can be made positive or increased or decreased on varying the potential difference between the photosensitive plate and the collector plate. So for a positive potential or for some positive potential, all the electrons will be collected by the collector and the current will be increased, right? All the this electrons will be collected by the collector. Further, if we increase the potential or for some potential difference, all the electrons will be collected by the collector and there is no current. So that current is, the current will be maximum there. That current is called as a saturation current. So when the potential is of a collector current is made negative with respect to the photosensitive plate, the electrons will be repelled by it and the electrons which have the capacity to overcome that opposition, which have sufficient kinetic energy to overcome, will reach the collector and there will be some decrease in the current. So for some specific negative potential of the collector current, the potential, the current will be 0. That current is called as a stopping, that potential is called as a stopping potential or a cut-off potential. That is mentioned it as a V0. Stopping potential or a cut-off potential. So this minimum specific potential through which the electrons, there is no flow of current, that is called as a stopping potential or a cut-off potential. So it is at that point, it is having the maximum kinetic energy for the emission of the electrons. So that will be half m v square, v0 square maximum is equal to ev naught. that is half m v naught square maximum is equal to EV naught. Okay. So half m v naught square maximum equal to EV naught. So here this if it increases the intensity of incident radiation for a specific frequency or a incident frequency of incident radiation, if you increase the intensity there, this stopping potential does not depend on the intensity of a incident radiation. So it is independent of the intensity of the incident radiation. Okay. And for any intensity of incident radiation, the stopping potential will be remain same because they are not depending on it. If they are depending on it, they should also vary, right? So it does not depending on the intensity of the incident radiation. So this is the effect of potential on the photoelectric current. So third one is a effect of frequency of incident radiation on stopping potential. Photoelectric current potential, this is retarding potential. Okay, this is a diagram photoelectric graph photoelectric current versus the potential. So here, if the intensity of the incident radiation and the photosensitive plate is kept constant, okay, effect of we are going to the frequency versus the stopping potential, right? Before that, if you keep the photosensitive plate and the intensity of the incident radiation kept constant, as we increase the frequency of incident radiation, the stopping potential also increases. They are directly proportional. So as does the maximum kinetic energy of a emitted electron or photoelectrons is directly proportional to the frequency of the incident radiation. So if you again draw the graph versus frequency of incident radiation versus stopping potential, stopping potential versus frequency of incident radiation. Okay, if you draw the graph frequency of incident radiation versus stopping potential, okay, so there will be some frequency at which the stopping potential will be 0. So that is the threshold frequency. I mean, threshold frequency is the frequency it is a frequency below, that is a minimum frequency below which the photoelectric emission is not taken place. That is a threshold frequency. So here the stopping potential will be 0 at that point. So here you can see the effect of frequency of incident radiation on the stopping potential. So these are the 3 effects on according to the photoelectric effect. So next about the laws of photoelectric effect. Now I have did the graph for these effects, right? The effect of intensity of incident radiation versus the photoelectric current, and the effect of potential on a photoelectric current, and the effect of frequency and on a stopping potential. On the basis of that only, the law of photoelectric current, I mean photoelectric effect. So it is mainly, it is 4. So the first one is the, for a given photosensitive surface, the minimum frequency called threshold frequency below which there is no photoelectric emission is taken place. Okay. For a given photosensitive surface, the minimum frequency called threshold frequency below which there is no photoelectric emission is taken place. That is the first law. And the second law is for a given photosensitive plate, the photoelectric current is directly proportional to the intensity of the incident radiation, and provided the frequency must be greater than the threshold frequency. For a given photosensitive surface, the photoelectric current is directly proportional to the intensity of incident radiation, provided the frequency must be greater than the threshold frequency. And the third one is the photoelectric emission is an instantaneous process, because there is no time lag between the intensity of incident radiation and the emission of electron. The photoelectric emission is an instantaneous process. There is no time lag between the intensity of incident radiation and the emission of the electron. And the fourth one is above threshold frequency, the maximum kinetic energy is of a photoelectron is directly proportional to the frequency of incident radiation. Okay. The fourth one is what? Above the threshold frequency, the maximum kinetic energy of an emitted electron is directly proportional to the frequency of incident radiation. So these are the 4 laws of photoelectric effect or a photoelectric emission. So in this session we have discussed only about the effect on the observation of photoelectric effect and the law of the photoelectric effect.